Hello students. So now we are going to start with our new chapter, that is vectors. So in this this is also a basic of the what we use in our physics for JEE, and it is just a basic how we use the vectors. Actual vectors chapter is also in mathematics. So we going to study vectors up to the level what we need in physics, okay? So in this video particularly we are going to discuss about the vector basic, how we denote the vector and types of vector, and angle between the vectors we are also going to define. What is the angle between the vectors, and we're going to see different examples also. So first thing which we're going to see here is that first we define something which is physical quantity, what we call as physical quantity. So any quantity which can be measured is called physical quantity. So any quantity, like you can measure a length, so it's a physical quantity. You can measure a weight, it's a physical quantity, okay? Like that there are physical quantity. So you can measure force, that is a physical quantity, okay? You can measure current, so that is also a physical quantity, right? So now physical quantity also we classify in two parts, okay, on the basis of the they have the direction or not. So we call as scalar quantity and vector quantity. So scalar quantity is basically what quantity which have only magnitude, there is no direction, okay? And vector quantity is basically for those quantities for which you have to define their magnitude as well as their direction, okay? There is a meaning of direction in them. Like force, if you say force, so on a body in which direction you are applying the force, that will matter, right? Okay, so that's why we have to define the force magnitude as well as direction. So force is a vector quantity, we can see, okay? Mass, you don't define any direction, which direction the mass, there is no sense of saying that, right? So mass is a directionless quantity. Length, temperature, similarly time, and here velocity in which direction particle is going, right? That direction is velocity. So velocity you define magnitude as well as the direction. Acceleration, which direction particle have a acceleration, okay? So this is the few examples of scalar and vector quantity. Now let's understand how to denote vector mathematically, okay? So this is how we denote a vector. A, just I will denote it like this, a and vector sign ahead about it, or I just a and then just dash, okay? So this is also a vector. How we denote the magnitude means there, as we said, vector have a magnitude and direction, okay? So this combinedly denoting the vector magnitude and direction both, okay? So if just we want to denote the magnitude only, then we will give a mode to him, okay? Or just we write capital A like A, that's all. We don't put a vector above that. So that's a magnitude, denoting a magnitude. And if we just want to denote the direction only, not the magnitude, then we define as a cap. Okay, how we read it? A cap, okay? Let me write it again, a and like this, cap. So the a vector is just a multiplication of its magnitude and the direction, okay? This you have to remember. So a vector is magnitude into direction, okay? So any vector is tells me the magnitude in a particular direction also, okay? Now let's understand graphical meaning. So when we are denoting a graph like this vector like this, what it means, this point just behind, okay, this is your tail, and this arrow side is your head, okay? And the length of this, so length of arrow is proportional to magnitude of vector, okay? The higher your magnitude, the longer will be your vector, okay? Something like we can say, so like if you are denoting one magnitude vector like this, so for two magnitude vector you will denote with double length. It's like this, okay? I hope you understood this thing, okay? So what we can say here is direction of a vector is always directed from tail towards head. So from here vector is starting from tail and it's going towards the head, okay? So this is the direction from tail to head, okay? This is the direction of the vector. Now let's go ahead with our next topic, that is types of vectors. So we are going to study many types of vector, and this is very good important topic, very easy and important also. Sometimes just a simple easy questions is asked and people are not able to answer, so that should not happen with you. So we're going to see this, okay? Now first is equal vectors. So what we are saying is equal vectors is basically, let's say this is A vector or and this is your B vector. Then what we say for equal vector, that direction and magnitude both are same, means both vector are identical. Okay, A vector equal to B vector. Okay. Now next thing is unequal vector. So other than equal vectors, all the vectors can we say in unequal vector. So this is A vector, B vector, direction may be same and magnitude are different. Maybe magnitude same but direction are different. Okay, or maybe magnitude also different and direction also different. Okay, anything. So these we include in unequal vectors. Now next thing, parallel vectors. Parallel vectors means their direction is same. Magnitude can be different or can be same, but direction will be same. So A vector and B vector, then we can say A cap is equals to B cap. Okay, like that. Anti-parallel vectors, these are direction is just opposite. Okay, so if this is A B vector and this is your A vector, so I can say B cap is negative of A cap. Okay, negative means just oppositing, just changing the direction, flip. Okay, by 180 degree. Okay, next thing is negative vectors. Okay, negative vectors is just basically I'm saying this is A vector and you're saying this is B vector, so I can say A vector is equal magnitude but just opposite side. Okay, so A vector equal to minus B vector, that's all. Equal magnitude, if you take mod both of side, A magnitude equals to B magnitude, but direction is just opposite. Okay, next thing, collinear vectors. Okay, vectors lie on the same line. So this is basically two vectors lying on the same line. Now they can be opposite to each other and opposite to each other or parallel also. Parallel or anti-parallel they are possible, but they should be collinear. Collinear means lying on the same line. I hope you know the meaning of collinear. Okay, next thing we have is null vector. Okay, this is very important. Now see, null vector, what we say is vector having zero magnitude. Okay, if the magnitude is zero, okay, then that is known as null vector, and the direction of null vector cannot be defined. So we can't define the direction of null vector because it's a zero vector. We can say point vector. Okay, this is and is starting from this and ending at this only. Okay, means there is direction is arbitrary. Okay, direction is anywhere. This is like you can say this is point. Okay, I am drawing a bigger. Okay, so this is point. So direction can be anything, right? So you can't define that. So direction is not defined. And how we denote this? We can denote, like if you say A vector is zero vector, then we can define it zero vector, or you can define zero also. That is also a defining zero vector. Okay, or starting from A point and ending at A point, same point, that is also a zero vector. Okay, like that. Next thing is coplanar vector. So coplanar vector is basically vectors which lie on a same plane. Same plane means, like say in your screen, that plane only, and a page you can take a paper in plane only. There are two vectors which are coplanar. Okay, that's basically coplanar. They're not going to study too much in coplanar, but later on in your mathematics you are going to study coplanar in very in depth. Okay, next thing we have some note is very important. Note is here. Okay, so what we say in the note, all equal vectors are parallel vectors as well as, but reverse is not true. Okay, what we are saying is equal vectors are parallel vectors. So we can say, okay, you can verify this with, okay, all equal vectors are parallel vectors, but all parallel vectors are not equal vectors, because in parallel vectors maybe the magnitude is changing. Okay, so that time it is not equal vectors, right? Anti-parallel vectors are unequal vectors, but reverse may not be true. So what we are saying is anti-parallel vectors are unequal. So unequal property means other than equal, all are unequal, right? But anti-parallel vectors are unequal, but reverse may be not true. This is also okay. Negative vectors are anti-parallel vectors, but reverse may not be true. This is also okay. Due to parallel shift, a vector remains unchanged. This is very, very important property. Okay, what this property is saying, let's explain this. Let's understand this thing. Okay, let me, if I have two axes, let's say like this. Okay, xy axis. Okay, and I have a vector here, let's say. Okay, this much magnitude, and it is making a, with positive x-axis, it is making angle theta. Okay, so what can I do is I can parallelly shift this vector, having its magnitude same direction and its direction is also same. Okay, I can parallelly shift it. So parallelly shift means keeping the magnitude same and keeping the direction same. Means it is making a same angle theta with the positive x-axis and having the same magnitude. Then it is okay. Okay. Still I can shift here also, parallelly shifting, same angle, same magnitude. I can shift it here also. There is no problem in that. Okay. So this property is telling me due to parallel shift a vector remains unchanged. So I can parallelly shift it from here to here. That we use. Okay. It is very useful property and it is very important property also. Okay. So you have to remember this. This is how you shift. Okay. You can shift from here to here or here to here, anywhere. Okay. That's your property. But you should not change its direction and you should not change its magnitude. And then you can parallelly shift it. Okay. Now let's go ahead with our next thing, which is angle between vectors. Okay. Now let's define angle between vectors. So if I say this is A vector and this is B vector, okay. So what I am saying is this angle is your theta. So theta is basically the angle between the vectors. So what you do for the finding the angle is, I have told you that you can parallelly shift the vectors, right? So you will parallelly shift the vector and you will connect the tail to tail. Okay, this is the tail to tail connection, tail to tail, or what you do, or you do head to head. Okay, you will parallelly shift it, the one of the vectors or maybe both of them, and you will connect them and you will find out the angle between them. So this is basically your angle between the vectors. Okay, this is how. Okay, but this is a step which I told you. Okay, you will parallelly shift and you will connect tail to tail or head to head, and then the less angle, okay, one will be 180, more than 180, and one will be less than 180. Okay, so you have to take the less than 180 angle. Okay, that will be your angle between vectors. Okay, now let's do some questions on that. Okay, so first question we have is A vector and B vector, and this angle is given 120 degree. Okay, now you can answer this. Okay, you can pause the video and you can answer this, and let's solve this. Okay, so I will just draw a dotted line, and now let me shift this A vector here, because these vectors are not connected head to head or tail to tail. So I will shift this A vector. Now this is, if this is 120, this is 60 degree. Okay, so the 60 is basically the angle between A and B. Okay, so angle between A and B angle is 60 degree. That's how. Okay, now let's do one more question. What is given here? A vector, B vector and C vector. Now if you see here, there are C and B are pointing origin, on origin they have their tail, but A don't have. Okay, so let's shift the vector A. So if I shift this one vector A, I will have all the vectors on here, on the tail, on the center, on the origin. Okay, so that's how I shifted the A. Now I can find out the angle between them. Okay, so basically A vector and B vector, B vector and C vector, C vector and A vector. So these angles I can answer. So A and B, so A and B, if this is 60, this is 30, so this will be how much? 30, right? B and C, so B and C I can say this is 90, this is 45. Okay, so how much? 10C. B and C I can answer 90 plus 45, that is 135. Okay, and C and A, C and A I can say 60, 180 minus 60 and minus 45, so 45 plus 30, how much? 105. Okay, this is your answer. I hope you will able to understand. Okay, just you connect head to head, all the heads should be connected, or all the tails you connect. I mean all from, if I shift A vector, all tails are connected and I can answer as very fast. Okay, so that's why I shifted just A only. Okay, now let's go for the C part. So now in C part, if I see the question, they are already connected head to head, so I can answer directly. 120 degrees is the answer. Okay, 120 degree, I answer directly. Now let's see the D part. Now D part is very interesting here. Okay, people are not able to answer this very instantly, but we will do, like we have to find out A to B. Let's first me write down what we have to find out. So we will get the A and B, A and C, A and D, then B and C, B and D, and then C and D. So 3, 3, 6. Okay, so this 6 we will answer here. Now let's see. Let's draw the axis and parallelly shift all of them. Okay, one by one. Now let's first A. I will keep the tails here. Okay, let me draw. This is my A vector. Okay, now A, if you see from here, B is pointing towards this point. Okay, towards the here. So if you see here, A and B angle, what angle is it between A and B? 60 degree, right? So I can draw B here, right? Right. I can draw B here. The angle between them is 60 degree. Okay. Now between B and C, I have angle 75, right? So between B and C, I have 75. This is approximately I'm drawing. So this angle is 75. Okay. And then between C and D, I have 80 degree. So I can say this is your D with an 80 degree. Okay, I hope this is clear. Okay, just I drawn for this x and y axis just for reference. You can't, if you wish, you don't draw it. Okay, that's all fine. Okay, now I hope you will able to resolve this. Okay, and you will able to answer this all. So you have to answer that there will be one angle which is more than 180 and there will be one angle which is less than 180, and you have to answer the angle which is less than 180. Okay, always. Okay, we have read this property. 60 degree this will be, and this will be 75 degree. Okay. Sorry for that. A and B, there it will be 60 degree. Okay, then A and C, that will be 135 degree. Okay, I'm directly writing down. A and D, that will be your 145 degree, and B and C, that will be your 75 degree. Okay, B and D, that will be 155. Okay, less than 181 you have to take. C and D, okay, that will be 80 degree. This is very easy question. Okay, no need to explain. So we can do one, A and D we can try. Okay, so if I take from this side, what will be it? 60 plus 75 plus 80. Okay, but I think this will be bigger. Okay, so what I will take is 360 degree minus 80 minus 75 minus 60. From the other side I have went directly from A and D. So this will come between A and D. This is gonna come 145, the lesser one. Okay, so other side if you go, that will be gonna come 180 plus 35, right? Okay, so that will be bigger. So that's why you will go for this one. Okay, it's like this. I hope this is clear. Okay, so thank you for this video.